Let's go ahead and do our last example, guys. Last example of the lesson is example 4. And once again, our goal is to solve for x. So whenever you're asked to solve for x and you have a quadratic expression, one of the methods that you can use is factoring using the diamond method. So that's what we're going to go ahead and do here. I want to go ahead and identify a, b, and c. And once again, I get these from the general formula. A in this case is the leading coefficient. If we take a look at this here, there's actually no number in front, but technically there is. It's invisible. It's actually an invisible 1. Our b value in this case, guys, is actually our middle term, which would be a -5. And our c value is a constant, the number that has no variable whatsoever. So once we've identified our a, b, and c values, we can go ahead and build our diamond. And on top of the diamond, we have a times c. On the bottom, we have a b value. So then in this case, guys, a times c would go on top. Our b value would go on the bottom. So let's go ahead and check this out. We have a times c in this case is going to give us a -14. Our b value is a -5. So the two remaining spaces in this case, it's basically indicating that we need to find two factors. Two that multiply to a -14, but add up to a -5. So if we think about it, we have our factors of 2 and 7. In this case, since my 5 is negative, I'm going to go ahead and make the 7 negative. So from here, we already have our factors. We want to go ahead and now move on to finding our binomials. So in this case, based on our leading coefficient, on our a value, we could determine that, there's no need for us to do grouping. We're basically done with factoring. So let's go ahead and write the binomials here. Our binomials in this case would be x plus a 2 and x minus a 7. And all of this here in this case is equal to 0. So we're done with the factoring portion. Now we still need to work our way to solve for x. In order for us to solve for x, we're going to go ahead and make each of the equations equal to 0. So I'm going to go ahead and break that apart. We have x plus 2 equal to 0, or we have x minus 7 equal to 0. So I will be on my left hand side subtracting 2 to both sides, and we have x equals -2, or I'm going to go ahead and add 7 to both sides. X is going to be equal to a 7. So these two values will represent our x intercepts, or the solutions for x in this case.